Let's learn how to implement JsonWebToken authentication in Actix-Web. First, let's go to cargo.toml file. We need to add some dependencies to our project. First, we add Actix-Web for backend server, Argon2 for hash password, JsonWebToken, and thirdly, so we can deserialize JSON value. And SQLX, we will use SQLX to connect to Postgres database. Then let's go to main.rs file. In terminal, let's first go to Postgres database shell. Let's create a database for our project in Postgres. So let's create a database. Let's give the name Auth. Then semicolon. Let's press enter. Database here. Let's press enter. It will tell us create a database. Then let's connect to this database /c and auth. Then we will connect to this database. Let's create a table in this database. Create a table. Let's give the name users, a pair of parentheses. Then let's add a field ID. We'll give the type of serial and a primary key. So this field will be unique and also automatically increased. We don't need to insert a value for this ID field. Second field, let's give the name username. Type give it a varchar 255. Let's add a third field, password. Also type is varchar 255. Let's add this pair of parentheses. Then with semicolon, let's press enter. It will tell us create table. Let's first define a struct type user rec. We use this struct type to get the user input username and password from request body. So it will have two fields. Username type, we give it a string. Password, we give it a type also string. Then we need to add attribute derive deserialize. So we can deserialize JSON value from request body to this user rec type value. Let's define another struct type user SQL. We use this struct type to interact data from database. Let's add three fields for this struct type, just like this users table, ID, username, and password. So ID type, let's give it a i32 integer type. User name, give it a type string. Password, also give it a type string. Then we need to add attribute derive from row, import from SQLX, reload from row. So we can use this struct type to interact with Postgres database. Let's define a function to hash the password. So fn hash password. Let's add a parameter to this function, password. Let's give it a type ref string. Return type, we give it a type string. In this function, let's first create an instance of argon2. So let's create a variable argon2 equal to, we will call argon2 import from argon2 default function to create a default instance argon2. Then let's create a sort equal to, we call sort string generator function to generate a sort. Then we'll pass a reference mute operator system RNG as argument. This is operating system random number generator import from argon2 random core OS RNG. Then let's hash the password. Let's create a variable hash the password equal to, we'll call argon2 the hash password method. To call this hash password method, we need to import password hash treat from argon2. Then you can call this hash password method. First argument will pass this password. Then we need to call @base method to convert this password from string to bytes. Second argument will pass a reference to the sort. Then let's call unwrap to handle the result. Then let's call toString to convert this to string. Last, let's return this hashed password from this function. Let's define a function to verify the password. So verify password function. Let's add two parameters. First one, password. We give the type reference string. Second parameter, we give the name hashed password. We give it a type also reference string. Return type, we give it a result type. First type in its result, we give it an empty pair of parentheses. So if the password is right, then it will return an OK, hold nothing. Second type is arrow type. We give it an arrow type from argon to password hash arrow. This function, let's first create an instance of argon2. So let argon2 equal to argon2 default. Then let's create a variable parsed hash equal to, we will call password hash new function to convert this password from string in PHP string format. We will pass this parameter passed hash word as argument. Then we will call unwrap to handle the result. This will be password hash format. This password hash. Then we will call argon2 verify password method. First argument will pass this password parameter. This password parameter is user input password. So let's pass password that we will call @bytes to convert it to bytes. Second argument will pass this passed hash. So ref passed hash. This passed hash we get from this hashed password. This hashed password is from database. If the password is correct, this verify method will return an OK, hold nothing. If the password is incorrect, this verify password method will return an error, hold a password hash error. Let's define a struct type claims. We use this claims struct to generate a JsonWebToken. It must have two fields. First one, ESP, stand for expiration time. We give the type usize. Second field, sub, stand for subject. We use this field to store some user information. Because the username will be unique, so we will store the username in this field. We give the type of string. Then we need to add attribute derive, deserialize, and serialize. Let's define a function to generate a token. So let's give it a name generate token. We'll add a parameter with the name username. Type we give it a string. Return type we also give it a string. In this function, first let's create an instance of this claims. So let's create a variable claims equal to claims. First field EXP expiration time. So system time now duration since Unix epic unwrap as seconds, convert it to seconds. Then we need to convert it to usize as usize. Then plus 60 times 60. So 60 seconds times 60 equal to 1 hour times 24 equal to this equal to 1 day. So this token will expire after 1 day. Then let's add server field will pass its username as a value to its server field. Then let's create a variable token equal to, we will call encode function from JsonWebToken. First argument will pass a header, will pass a default header reference header from JsonWebToken default. Second argument will pass a reference its claims instance. Third argument will pass a key, so we'll pass encoding key from secret. Then let's create a secret. Let's create a global variable secret. So static secret will give it a type annotation ref str equal to, we just give it a value secret. If your project for production, you shouldn't use this simple secret. Then here we'll pass a secret as argument. Then we need to call as bytes to convert to bytes. Last, let's call unwrap to handle the result. Then let's return this token from this function. Here, we should add a reference to its encoding key. Let's define a function to verify token. So let's define a function, give the name verify token. We'll add a parameter token type, give it a reference str. Return type, we give it a result. First type in this result, we give it a string. Second type in this result, we also give it a string. We will call decode function from JsonWebToken decoder. First argument will pass this token, and the second argument we will pass a key reference decoding key from secret. We also will pass this key, so this global variable secret as argument. So here secret, we need to convert it to bytes, called as bytes method. Third argument will pass validation, the ref validation from JsonWebToken will pass a default validation. This decoder function will return a result, so let's use the match expression to handle the result. If the token is valid, it will return OK. Hold the token data. In the arm, let's get the claims from this token data. So let's create a variable claims. We'll give it a type annotation. This claims struct type we created before. Then token data the claims to get the claims from this token data. Then we'll return OK. Hold the claims the server. Second arm after this OK. If the token is not valid, this arm will be error. This error will hold the error message. We give it a name E. Then we'll return this error E in error. So error E. We need to convert this error to string. So we need to call toString method on this error E. Let's define a sync function to connect to database. We give the name DB. Return type will be PJ poll. Let's create a variable poll equal to, we'll call SQLX Postgres PJ poll connect function. Then we'll pass a connect string Postgres colon // then username, my username is Mike, colon, then password, my password is 12346 at local host colon port 5432 / is a database name auth. Then let's call await to handle the future and wrap to handle the result. Last, let's return this pool from its function. Let's define a handler to register user. So a sync function, let's give the name register. We'll add two parameters. First one, let's add a parameter, give it a name user rec. Type will be web JSON. Hold the user rec type we defined before here. We will use this parameter to get the user input username and password from request body. Second parameter, let's get the database pool from shared state. Let's give the name pool. Type will be web data pj pool. Return type, we give it a IMPL responder. Let's add an attribute to specify the request method post and give it a pass register. First, let's check username and password from request body not empty. So if user rec the username the trim, we will trim white space equal to empty string, or user rec the password equal to empty string. Then we'll send a response http response by the request body. Let's add a message like a username or password must not be empty. Let's add a toString to convert a toString. Else, if user input username and password are not empty, then let's check whether or not this username already registered. We want a username is unique, so we don't want the same username registered twice. So let's try to find the username from database. Let's create a variable. Let's give it a name Rose. Type, let's give it a whack. Hold the user SQL equal to, we will call SQLX query as function. Then let's write a SQL select asterisk from users, this users table. Then we will add a while condition. Username equal to placeholder $1. Then let's call bind method to bind the parameter ref user rec its username. Fetch all. We'll pass a database pool as argument. So pool get ref to get the pj pool from this shared state pool. Then let's call await to handle the future and unwrap to handle the result. Then let's check if rows line equal to 0. This means there's no elements in these rows. So it means we didn't find any user registered by this username. So we can register new user by this username. Then we need a hash the password. So let's create a variable hash the password equal to, we'll call hash password function we defined before. We'll pass a password from user rec as argument. So ref user rec the password. Then let's insert a username with this hashed password into the database. So SQLX query function insert into users user name and password values $1 for the first placeholder username $2, second placeholder for password. Then we call bind method to bind the ref user rec username. We will call bind again to bind the second value hashed password to replace this second placeholder $2. Then we will call execute method. Also, we'll pass this pool.getRef as argument. Then we need to call await to handle the filter, unwrap to handle the result. Then let's send a response http response OK body register user successful toString. Here let's add else. If this rows length not equal to 0, it means we find a user by this username, so we will not allow user to register a new user by this username. Let's send a http response by the request the body. Username is already taken. Please change another username. Let's define another handler to log in user. So async function login. We also will add two parameter. First one is user rec. Type is web JSON user rec. We'll get a user input username and password from request body. Second one is pool. Web data pj pool to get the shared state database pool. Return type also will be MPL responder. Let's add an attribute to specify the request method post. Let's give it a path slash login. First, in this handler, we also need to check username and the password is not empty. So let's call p here. From this register handler, if the username or password is an empty string, we just send a response. Username or password must not be empty. Else, then we need to find the register user by the username we get from user request. So let's copy this. We will find the user from database by this username from this request. Then let's add a if else expression. If rows length equal to 0, it means we didn't find any user from this database. So it means this username is not registered. We will send a HTTP response by the request body. Username is not registered. Else, we find a user by this username. Then we need to verify the user input password from request body. So we will call verify password function we defined before. Here, then let's verify the password from user input. Then it's the password we get from database. So first we will pass ref user rec the password. This we will get the password from user input password from request body. Second, let's get the hashed password from database. It will be ref rows. So if we find a user by this username, it will be in this rows. It will be the first element in this rows. So index number is 0. Then password. This function will return result. So let's use match expression to handle the result. If the result is error, hold the arrow E. We will send a HTTP response unauthorized body E to string to convert to string. Second arm, if the password is correct, it will be OK, hold nothing. Then we will generate a token. So we call generate a token by the username. So username we will get from user_rec.username. Let's create a variable token to store the token we get from this function. Then we will send a HTTP response. OK body. This body will hold this token. So we will send this token in response. Here, we will call clone method to clone this username. Let's define a middleware to verify token. We will define a single function. Let's give it a name auth. We will add two parameters. Rec will be server's request. Second parameter is next. Type will be next. Hold a box body. Return type we give it a result. First type in result we give it a server's response. In server's response we give it a type box body. Second type is arrow type. Import from Actix-Web arrow. So let's import arrow from Actix-Web. First, in this middleware, we will get the header value from its request. So rec.headers.get will pass a key as argument. Key will be authorization. It will return an option, this get method. So we will use match expression to handle this match. So first if the option is null, it means we didn't get any value by this key authorization. So we will send a response in OK, rec.into response. Then we pass a HTTP response, unauthorized body, no token found. Second sum. If we get the value by this key, it will match this sum pattern. In sum, it will be header value. So we add a variable header value. In sum, let's convert this header value from header value type to string slice type. So let's create a variable header value to shadow this header value equal to header value to str. Then we need to call wrap to handle the result. It will be string slice value. Then we need to check if this header value start with beer. Normally we will send the token start with beer. So if header value start with beer with a white space, let's first add else. If this header value not start with beer, let's send a response in OK. Rec OK, rec into response, HTTP response unauthorized body. We will give it a message valid token. If the header value start with beer, then we need to split this header value to get the token from its header value. So let's create a variable token equal to header value split by white space. It will split this header value. First element will be this beer. Second element will be token. Then we need to call collect method to convert this in a vector. So we give it a type annotation vec hold string size reference str. Then we will get the second element. Index number is 1 to get the token. Then we need to verify the token. We will call verify token function we defined before to verify this token. Let's use match expression to handle the result. This verify token method return. So match verify token we pass a token as argument. First we pass a pattern error. This error will hold a error E. It means this token is not valid, so we will send a HTTP response in OK. So here let's body in this body let's change to this arrow E. Second pattern will be OK. This means its token is valid, and this OK will hold the sub. Then we will insert this sub into request. So rec the we will call extensions mute method on its rec to insert its value. To call this method, we need import HTTP message from Actix-Web. So after we import HTTP message, we can call extensions mute insert method. Then we will insert a sub. Last, we will call next. The call will pass this rec as argument. Then we need to call await to handle the future. Let's define a handler for the protected router. So let's define a sync function. Let's give it a name protected. We'll add a parameter rec. Type will be HTTP request. Return type MPL responder. Then let's add an attribute to specify the request method get. Then let's give it a pass slash protected. Then let's get the sub from its request we passed in this middleware. So rec the intentions the get. We will give it a type annotation string. Because this sub is string type, we will get a string value from its rec intentions. Its get method will return an option. Let's use the match expression to handle the option. If the pattern is null, we didn't get any user, we will send a HTTP response not found the body, no user. Second sum will hold that sub. A sub is a username. Then we'll send a HTTP response OK the body. This body let's call format method to format a message hello. We'll pass this sub in this format. Here let's add a exclamation mark. Let's go back to main function. In main function, let's first add attribute Actix-Web main, so we can add a single keyword for its main function. Its main function will become a single function. Let's first get a database pool by call this db function .await. Then let's start HTTP server from Actix-Web. So HTTP server new function will pass a closure as argument. We add a move keyword to move the ownership to this closure. In its closure body, we will call app from Actix-Web new function to start a new instance. Here, we will call Apple data function to add a shared state. We'll pass its pool as shared state. Data new pool. We need a colon is pool, so colon. Then let's use servers to add a handler to its server. First, let's add a register handler. Servers, let's add a login handler. Then let's add another servers. In this servers, we'll add a new scope. So web scope, let's give it a pass slash like a API. In this scope, we'll add a middleware. So we will call wrap method from function. We'll pass this middleware auth here. Then let's add a root, this protected root to this scope. So protected. So its middleware only will work on this protected root. This middleware will not apply to its register and login root. Then, after we add all the routers, after this HTTP server new function, we will call bind method to bind the address. This server will listen on 0.0.0.0 port 3000. Then we need to call unwrap to handle the result. Then we need to call run method to run this server. Then we need to call await to handle the future. Last, we need to call unwrap again to handle the result. Now we can start our server. Let's open a new terminal. We'll run cargo run. We use Postman to test our server. In Postman, let's open a new tab. We'll choose HTTP. Let's first visit a protected root, localhost 3000/API/protected. Let's send this request. So you can see it will tell us no token found because we didn't add a token to its headers. First, let's register a user. We will change this request method to post localhost 3000/register body role JSON. First field is username. Let's give it an empty username. Password. Let's also give it an empty password. Let's send this request. We'll get a response. Username or password must not be empty. Let's give it a username like Jim. Let's give it a password 123456. Let's send this request. We got a response. Register user successful. Let's try to register same user twice. We'll get a response. Username is already taken. Please change another username. Let's open a new tab. Let's change the request method to post. Let's visit localhost 3000/login. Let's try to log in user. Here, let's choose body, role, JSON. First field is username. Let's give it an empty username. Password. Let's also give it an empty password. Let's send this request. We will get a response. Username or password must not empty. Let's give it a username like a PAM, not registered in the database. Let's give it a password like 123. When we send this request, we get a response. Username is not registered. Let's change it to username Jim, password 123. We'll get a invalid password. Then let's change it to the correct password 123456. So we will get a token. Let's copy this token. Let's go back to its protected root. Here, this header will add a key authorization. First, let's pass this token, not start with beer. Let's send this request. We will get a response on valid token. Then let's add a beer at first with white space. Let's send this request. So you can see we got a response. Hello, Jim. If we change this token, like we add a 1 at the end, so this token will be not valid. Let's send this request. You can see it will send a response invalid signature. And this is how we implement JSON Web Token authentication system in Actix-Web. Hope see you next time.